Hello, everyone. My name is Andriy, and I'm one of the student technicians at HPRC, which stands for High Performance Research Computing. And we provide essentially high performance computing resources to researchers and students here at Texas A&M. And today I'll be teaching one of our primers on data management practices, because when you deal with these resources that use a lot of computing, they also use a lot of data, and having good practices of how to manage those data is really important. And yeah, we uh, we have a lot of our help desk members and full-time staff members part of this call. So if you have any questions, feel free to put them in the chat. And we also try to make this session as interactive as possible. So we're going to have some interactive portions during this presentation, and I encourage everyone to follow. Uh, uh, so let's get started. And first, I'll just mention some of the resources that HPRC provides. So a really good resource is our knowledge base. A lot of the material that I'll be mentioning here today, you can read more about it on our knowledge base. And so you can see the link here, and also in the chat, we should post the link for our slides, so you can find it there. And another great resource is our website, where we post, for instance, announcements for events like these primers. You can find a lot of useful information there. And also we have our YouTube channel, where we have a lot of our primers, short courses. All the recordings of them are posted on our YouTube channel. So this is also a really great resource to expand your knowledge about our resources. And as I mentioned, we provide a lot of computing resources. So we have currently 4 clusters that we manage. These are listed here on the left. These are ACES, Faster, Grace, and Launch clusters. And to use them, there are 2 options. If you are a Texas A&M student or staff member, you can access Faster and Grace clusters by requesting an HPRC account. And for Faster, ACES, and Launch clusters, you can access those by using Access ID, even if you're not a Texas A&M student or staff member. So this is available to everybody. And if you want to learn more details of how to request to get those Access IDs or HPRC accounts, our knowledge base is a great resource. And we also have primers that give introduction to all of these different clusters, which you can find on our YouTube channel. So as I mentioned, this session will be very interactive. So I encourage everyone to follow along. And in order to do so, we want to access these clusters. And a convenient way to do so is through a web browser. So we can either go directly to the portal.hprc.tamu.edu web portal, or we can just go to our website, hprc.tamu.edu, and then in one of the drop downs, in the portal tab, you can select which cluster you want to log in. And after you log in into the portal, you can open a Linux terminal through one of the options on the dashboard here. So there will be many different options, among which there is clusters. And you can select Grace shell access, or whichever cluster you're on, to open a shell where you can run all of your Linux commands. So let's try to do that. Let's try to log in into the Grace cluster, where we'll be doing majority of our examples during this primer. And we'll try to go into the online portal. And also just a note, if you're connecting to this primer, or if you're trying to access the portal not from within TAMU Wi-Fi, you would first have to set up a VPN. And to set up the VPN, I think knowledge base should have, well, it does have research of how to do that. So you can refer to that. But I'm going to go ahead and try to open the portal through the website. So I open a new tab and I type in hprc.tamu.edu. And from here, I should be able to log into the website. And I encourage everyone who's on this call to and who's watching the YouTube video to follow along, because it's the best way to learn this new material. So we're going to try to log into Grace portal. And when you try to go to the Grace portal, it will likely prompt you to log in and input your credentials. So if you could do that, that'd be great. And if you could put in the chat, say something in the chat or raise a hand saying that you were able to log into our portal, that would be great. Okay, I see someone's being able to do so. That's great. Nice. I'm trying to open the chat here so I can see everything more clearly going forward. All right. And as I mentioned, once we're on the portal, okay, so once we're on the portal, if we go to the clusters tab, we can open Grace shell access right here. And after going into this shell, we'll need to input our credentials again. So we need to put our password, and then we need to do the two-factor authentication. So we'd have to use the Duo. And after doing this, we should be able to see the welcome message, which shows our quota, which we'll cover in just a second. All right, so I think I'll move forward. All right, so as I mentioned, this is a primer on data management. So good data practices are a must. And a really good rule of thumb that we encourage everyone to follow is to keep a lot of backups of your important data. So 1 is none, 2 is 1, which means that if you have some very important data, you want to have at least 1 copy stored somewhere. Because if you lose that important data, if you have only 1 copy, it's lost forever. And this is something that you want to avoid at all costs. So backup, it's always important. If you're storing something on our clusters, maybe make sure to have some other drive where you store a copy of that data. So if it's important, you don't want to lose it. That's a really good practice to always keep in mind when dealing with important data. And talking about how the data is stored on our clusters, we have 2 main directories. And these are home and scratch directories. So you can see in the table here, there's a comparison between them. The home directory is intended to be used for small to modest amount of processing. So it has a much smaller space limit, and limit on number of files. So this is the directory where you don't want to run all of your computations and store all the data that takes a lot of space. This is more of the smaller data that is backed up. So, and the Scratch directory has a much higher space limit. So it has 1 terabyte and quarter of a million file limit. So this is a temporary storage area. So this data is not backed up. In contrast, the everything stored in the home directory is backed up, but the Scratch directory is not. So that's why we advise to store important data on some drive, apart from just the Scratch directory, for instance. And this is where you want to do all of your computations. So for instance, if you're cloning a GitHub repository or loading Python packages, those might contain a lot of files, which might not fit in the home directory. So you would want to use the Scratch directory for all of your main use cases of our clusters. But also important to keep in mind that this is not intended to be a long-term storage area. So yeah, just keep that in mind. Another important note is that the Scratch directory is shared between the Faster and Grace clusters. So those are common for both of those clusters, so we can easily share the files among these two clusters. And as I mentioned, these file systems have limits, or in other words, quotas on how many files you can have in them or how much space you can utilize in those directories. And you can view those quotas using the show quota command. If you run this in your Linux terminal, you would see the quotas. And you can also view that through our web portal, which we'll show in just a second. Another important note is that the home and Scratch directories are your personal directories. So if you're working with a group of people and you're collaborating, the Scratch and home directories are not intended for that use. If you're collaborating with other people, you might request a group directory that you will use to share and collaborate. So as I mentioned, on our web portal, we can open the dashboard where we can you can see all the quotas that you have for your directories, and you can also increase the quotas. You can send a request to increase the quotas through this portal. So you can see the home directory cannot be the home directory's quota cannot be increased, but the Scratch directory quota can be increased if you submit a request with a justified reason of why the quota needs to be increased. And if you run into any questions of how to do that, you can always contact us at hprc.tamwa.edu. So let's try to view our quota. Let's try to navigate to the dashboard and see the quota on the web portal, and then try to run the show quota command in our Linux terminal to see if we get same results or not. So again, I encourage everyone to try to do this. And if you're able to do this, just put something either in the chat or raise a hand in the call. So if I go to the web portal, I can go to the dashboard tab and select raise dashboard. And after it loads, we should be able to see somewhere this quotas in the tab right here. Right now, the Grace cluster is being used extensively, and it's might be a bit slow. In a second, we should see something show up here. And in the meantime, I also like to mention that if you have any issues that you're running into, you can always send a help ticket through our dashboard. So if you can either send us an email or you can use this button over here, and you can type in all the details of what you're running into so we can better assist you. So as you can see, we do see our home directory and Scratch directories show up here, and we see our quotas, and we see our current usage and the limit. And we can also increase the quota by pressing this button. If you're following along, you might not see this group directory. So as I mentioned, if you're collaborating with others, you would see group directories. You would create group directories that are the files among which are shared with whom you're collaborating with. So in my case, I do see this HPRC group. And I hope that everyone was able to open the dashboard. And another option to show to see the quota is, first of all, it's always shown the first time you log in into the Linux terminal. So you can see my quota is right here. But if I clear this by using the clear command, and I run, let me make it a little bit bigger. If I run show quota command, I should be able to see this message again, which shows the same information of my current, for instance, disk usage versus the limit for disk usage. So now we'll shift gears a little bit and talk about the command line tools of how to work with our data, with our files. And here's just a brief outline of the commands that we'll be using. So at first, we'll cover the copy and remove commands, which are useful for managing files on your machine, on just one machine. And then we'll talk about archiving those files using the tar command, so we can condense many files into single file, so it's much easier to use to use it. And then we'll talk about some of the commands to transfer files between different machines, such as FTP, SCP, and rsync. So let's get started, and we'll start with the copy command, which in Linux you would use cp, which stands for copy, to use it. And this command is very straightforward. It does what it intends to do. So when we want to copy a file, we would just run cp space the name of the file that we want to copy, space the file, the new file where the contents will be copied into. So this new file name, so the contents from the source file will be copied into the new file. And this is a very easy solution to copy a file on one machine. And if you want to transfer data between different machines, you would use either SCP or SFTP, which we'll cover in just a second. And another command that is often very useful is the rm command, which stands for remove. And it's also a very straightforward command, since when you want to remove a file, you just type in rm space the name or the path to the file that you want to remove. But just as a word of caution, when you use this command, if you remove something, you remove it permanently. So there's no such thing as a trash bin where you'll be able to recover the file. So you should be absolutely sure that you want to delete the file before doing this. And if you want to confirm that you deleted the file correctly, for instance, if you're deleting a directory, you want to say that I will delete each one of them, you can add this -i flag, which will prompt you to confirm that, yes, I do want to delete the file after running this command. So let's try it. Let's open the command line and let's create a test directory where we'll try to make a file, and we'll try to make a copy of that file, and we'll try to remove or delete that copy using the commands that we just learned. So if I go into terminal once again, if I clear everything that's currently present on the screen, I can first go into the Scratch directory where I will be doing all these examples. So I will use the cd command, which stands for change directory. And after I got into the Scratch directory, I can use the ls command to list all of the current files, all the current directories that I have in the Scratch directory. So you might see something different when you type in this command. And I will create a directory here called using the mkdir, which stands for make directory, called data primer. And I will go into this directory using the cd command again. So was everyone able to create a directory? If you could put something in the chat or raise your hand, that would be really helpful, so I know if I should move faster or slower. I see one hand. If I could see more people. Yeah, I see more people now following along, so this is great. Yeah, nice. We see more people doing it, so this is great. So now let's create a text file, and I will use the nano editor to do so. So to create a file, I would just type in nano and space the name of the file, which I'm very creative, so I'm just going to call it a.txt. And after I press enter, it'll open this text editor. So you can type pretty much anything into here. I'll just type in hello world. And after you type in the contents of the file here, you will need to first save the file. And you can do this using the Ctrl-O command and then press enter. This way we'll save the file. So Ctrl-O, enter, and then we can press Ctrl-X to exit from this nano editor. So press Ctrl-X, it closes it. So now if I run the ls command again to list all the contents of my current directory, I will see that a.txt is there. And I can now try to, for instance, copy the file using the cp command. So if I copy a.txt, and then I need to provide where I'm copying it into. So I will copy it into a_copy.txt, for instance. And if I run ls command again, I should see that I have a.copy there. And if I use the cat command, which stands for concatenate, but it will essentially output the contents of the file, and you can see that a.copy contains hello world. So if you were able to create a file and make a copy of it, let me know by raising a hand in Zoom or putting something in the chat. That would be great. All right, I'm gonna give just a few more seconds for everyone. And now let's try to use the other command that we've talked about, the remove command. So to use it, we just need to type in rm, and we need to put in the name of the file. So for instance, we want to remove the copy. We would type in the a_copy.txt. And after running this command, if we list the contents of the directory, we'll see that a.copy is no longer there, which means that it was removed successfully. All right, so I think we can move on then to the next commands. And the next command that we're going to cover is the tar command, which is used for archiving files. So essentially, if you have a lot of files, you have, for instance, a directory which has many of the files you want, and you don't want to copy each one of those files individually. So you can use this tar command to make your life a lot easier, because it allows to archive many files together into a single file. So for instance, using this command, we can archive an entire folder in just one .tar file. And to do this, we would need to run this tar command, followed by some flags, this dash something that would tell exactly what to do, what do we want this tar command to do. So some of the important flags are listed here in the table on the right. So for instance, the CF flag would create an archive. And you can see that to save many files together, you can run dash CVF flag. So V stands for verbose, which means that they will just output and log all the files that it has archived into this archive.tar. So you put in first the tar command, then the flags of what you want it to do. Then you type in the name of the tar file where all the files are going to be archived from the source. So you can also compress files in that archive by adding the Z flag. And with that, you can just save space by compressing the files in that archive. And now that you can archive the files, it would also be great to actually extract things out of that archive. And to do that, you can use the -xf flag in order to extract the contents of your archive. So you type in tar -xf and b if you want to output everything it did, and then you put in the name of the archive. So now let's try to use this archive command, this tar command, and let's try to make some copies of our test file that we've just created. And let's try to use the tar command to condense them all into just a single file. And then we'll try to extract them back. So if I go to my terminal, I can clear everything, and I can try to make copies of this a.txt file using the copy command again. So I can copy a.txt into, for instance, b.txt. And I can do the same and copy it into c.txt. So now if we do ls, we should have 3 files. So I see a question in the chat about whether the order of flags matter, and it does not matter. So you could see that if it loads, here we're saying dash CF, but in every command that we showed it was CVF. So the order doesn't really matter. It gets the same result done. So now that we have the copies of the file, let's try to go out of our directory using the CD and 2 dots. This will put us back into the Scratch directory. And the race is a bit slow right now for some reason. So now if I do ls again, I would see that I do have data primer directory here. And I can try to use the tar command with these CVF flags to create an archive. And I will call it, for instance, data archive.tar. And after that, I need to put in the name of the folder, data primer. And so if I run this, it would output all of the files that it has archived because of this verbose flag. So you can see that it has all of our files in the data primer directory. And now if I run ls to see the contents of my directory, I will see data archive.tar file present here. So was everyone successful at trying to do this? When you've tried it, just let me know with a hands up or something in the chat. I see another question about what does verbose mean. So if I try to do the same operation, for instance, data archive 1 without the v flag, you see that I do not get any output like this. So verbose just helps you to output all the files that were put into your archive. So you just know what you're archiving. It's not a necessary flag. Yeah, and also Josh has clarified one of my answers saying that the F flag should be last. So that's also a thing to keep in mind. All right, so I hope everyone was successful in creating the archive file. And let's try to now extract the contents of that file. So we can use the tar command again, and we just need to use different flags. So we would use the X instead of C. And let's also make it verbose. And we need to provide the name of the file, which is data archive.tar. So if we run this command, we see again all the contents have been logged, outputted, and they're the same. And now if we look in our directory, I've just realized that it's extracted the same folder. So let me just remove the data primer folder. And I need to use the R flag because if I don't use it, it will say that you cannot remove a directory. So I need to add an R flag, which stands for recursive. So it'll remove everything within that directory as well. So now if I look into my directory, I will not see the data primer directory. But after I run the extract command, I should see that this directory is now present. So if you could try it out and let me know if you're successful or if you have any questions, feel free to post them in the chat. All right, I see that tar does not want to open an empty archive. So the tar archive, if it's empty, it will probably give an error. Maybe that it doesn't want to open it, which I'm not entirely sure. But maybe when you were creating the tar archive, you used a folder without any files, and maybe that led to some strange behavior. So for instance, I try to create a tar archive, for instance, data empty. And if I specify, and if I try to specify, for instance, Oh, okay. So here I've tried to create an archive using the C flag down here. And I haven't specified the folder that I want to uh, con condense. I did not provide the source folder. It gave me this error. So maybe you should try to run this command again and specify the folder like this. Then it should create the tar archive. Also make sure that the directory you're trying to archive is present. So for instance, I use the ls command to list the directories that I can see from my current location. And I can see the data primer, which I've used to create an archive with it. Okay, it works. Great. Yeah, okay. So there's also another question about whether we can remove multiple files together. Yes, I believe that if we do the rm command and if we put data empty.tar and then we follow with, for instance, data archive1.tar, it should remove both of them. So you can just specify more files after a spacebar. And if you want to remove a folder, as I mentioned, you would need to have that -r recursive tag. So I think we should move forward. Now let's talk a little bit about transferring files between different machines. So the first thing is some of you might know that we have on our clusters login nodes and compute nodes. So whenever you log in into our cluster through a Linux terminal, you get into a login node. And when you want to submit a job, for instance, that job gets executed on the compute node. So we also have similar distinction between login nodes and data transfer nodes, where data transfer nodes are more well suited for transferring data. However, this distinction is not as strong as it used to be some years ago. So right now, in majority of the cases, you don't really need to worry about it. Because this 60 minutes that is stated here, it's not 60 minutes of time, for instance, on your clock, on your watch, on your iPhone. It's the clock of the CPU, so it actually will allow a lot of processing to happen within that time frame. So in majority of the cases, you don't really care about this distinction unless you're transferring really large files, or for instance, 100 gigabytes. And for other use cases which do not require this much of file transfer, you can just use the login nodes, and you can use the command line tools, SCP, SFTP, and rsync through those login nodes, and it would work for you. But if you're doing larger data transfer, Globus, which we'll mention a little bit later, is a preferred method because it uses those data transfer nodes, and overall it provides a easy to use interface. And also for even smaller data transfers, we also recommend to use some of the tools that provide graphical user interface because they're just simpler to use. But if you need to quickly move files from one machine to another, you can use the command line tools. But we'll cover those those other methods in shortly. So the first command that we'll cover is the SFTP command, which stands for Secure File Transfer Protocol. And it allows you to essentially connect to a host, for instance, in this example, to Grace. And when you connect to this host, it will provide an interactive shell similar to that Linux shell, where you will be able to use some of these commands below to, for instance, download files or upload the files on that machine. And it is sometimes might be used because it's available on pretty much majority of the machines that you'll be working on. And it's not recommended for very large file transfers because it has some limitations in terms of its speed. It only uses one data transfer stream, which makes it less preferable to some of the other methods. And another command line tool that we're going to talk about is SCP, which works somewhat similarly, but it doesn't provide the interactive component. So when you use the SCP, it works very similar to copy, but it provides an ability to copy files not just on your local machine, but also to some remote machine. So for instance, if we want to copy a file, we can use this command of scp space the source file of what we want to, where we want to get the contents from, similar to the copy command. And after a spacebar, we can provide, for instance, in the case of SCP, we can provide a remote address. So here we would put our net ID and a node, for instance, grace.hprc.tamu.edu or faster.hprc.tamu.edu. And then after a column, we can specify the path on that machine. And so, for instance, in this example, this source file, if we try to put Grace in here, it would get copied to the home directory on Grace. And similarly, we can also use this command to copy not just from locally to remote host. We can also copy from remote host to our local host, or just from remote to remote host. So it's pretty versatile in this regard. And it's also only use one data transfer stream, so it's not as fast in some cases, but it's pretty easy to use. So if you just need to copy a file quickly, it gets the job done. And another command that we'll talk about is the rsync, which stands for remote synchronize. And in terms of its usage, it's pretty identical to SCP in terms of its signature, that you just put an rsync, your source file, and your destination, and it copies the file. But the way it does it is somewhat different. So in a lot of cases, it might be faster than SCP, because the way it copies the files is that it copies only the differences of files. So maybe if you're familiar with Git, how it stores its commits, it stores the differences between the versions. And so if you are copying files that, for instance, copying files of newer versions using rsync, and the files are similar, then will be a lot faster than, for instance, SCP or SFTP. And because of the way it works, that it only copies the changes, it also supports intermittent transfer. So if something happens that interrupts the network and your transfer is interrupted, it's much easier to resume your transfer using rsync, whereas with SCP, you would have to restart it all over. And so let's try to use some of these commands. So let's try to use rsync command to copy a tar file, that archive that we've just created, to a faster cluster. And then let's try to verify that it actually arrived where we want it to arrive. So if I go to the Linux channel again, I'll clear everything here. So if I list the elements I see in my current directory, I see this data archive.tar file, and I can use the rsync command to specify that I want to copy the contents of this data archive.tar into the faster cluster. So I'd put my net ID followed by the host name for faster will be faster.hprc.tamu.edu. And then I would put a column, and I would specify the path on the faster cluster where I want to copy my data archive. So I put /home, and then I'll put my net ID. And this way it will put this data archive into the directory I specified after the column on faster. And if I run this, it will prompt me to log in my credentials to check if I can access faster. And then it will prompt me to do the 2 authentication again. And if I give it a second, if it does not create any errors, then it should work. And for those who are following along, if you're were successful in doing this, you could say something in the chat or raise a hand. That would be very helpful. So when you copy the file using this rsync, it doesn't say anything. So the way to figure out whether the copy was successful is to go on the cluster node. And to do that, we can either go to the HPRC website and go to portal cluster and then select cluster and go into the Linux shell again. We can also go to clusters, logging from the cluster. We can do the same as we did for Grace in the beginning. And so we see our quota once we logged in. And if we use the pwd command, once it loads completely, we can see our current directory, which is home / my netid. And if I do the ls command to list my items, I would see the data archive actually was able to be transferred successfully. So if you could raise your hand in chat if you were able to transfer the file using the rsync command, or if you have any questions, let me know. So you do the rsync space, the name of the file that you want to transfer, and after a space, the destination where you want to transfer the file to. In my case, it is my netid at pasture, because I'm transferring to pasture.hprc.tamu.edu. And then after a column, I specify the path, which in my case is /home/ my netid. I guess I will move on to the next command that we're trying to do. Okay, I see it. Comment that trader transfer works. Let's see. Oh, I see. So it's not just me that takes a long time with logging to different clusters. All right. Well, I think I will move on then, since the data transfer works, it's great. So we'll move on to the next topic, which will be the tools that you can use to transfer files not through the command line, but through a graphical interface. And for some reason, the PowerPoint has died again. So we start it one more time. And now I'll talk about some of those tools that allow you to transfer files through the graphical interface. And some of them you might be already familiar with, such as, for instance, MobaXterm or WinSCP or CyberDuck. We'll look at all of them in just a second. So these tools provide you an ability to essentially transfer files through a graphical interface, which a lot of you are probably more used to. And our portal actually provides an in-house, our own built portal, where if you go to the Files tab, you can open the directories on the web browser, and you can transfer files directly there. You can look through the files and edit them, and it's just a very good resource. Apart from that, you can also use other software, like for instance MobaXterm, which is available on Windows, where it provides a panel on the left where it shows all the files using the SFTP protocol on the back end of it. So you can also download or upload files using this sidebar on the MobaXterm app. Similarly, you can use WinSCP on Windows machines to do essentially the same things, to transfer and get the files using the SFTP protocol, but just with a nice user interface. Very similar, CyberDuck provides same functionalities, but is available not just on Windows, but also on macOS. And there's also Globus, which we recommend. We have our endpoints set up specifically for Globus that use these data transfer nodes. And Globus is a very great resource because it's available on all the operating systems if you want to use Globus Personal, which you can download. But you can also use it through a web portal, so it's very easy to access. And it uses, as I mentioned, our own endpoints. So for large data transfers over 100 gigabytes, Globus will be the best choice. And let's try to use Globus. So we can go to, we'll try to create some file in our home directory, either on Grace or Faster. And we'll try to go to Globus and try to transfer those files using Globus. So we would first search for our Grace DTN and Faster DTN in the collection fields, and I will transfer them. And I think it's best to showcase this using just sharing my screen as a demo. It'll be much clearer. So if we go to this link, which is app.globus.org, it'll get me to the Globus portal. But for a lot of you, it'll probably first prompt you to log in and enter your credentials. So there you would want to log in through an organization and select Texas A&M University. And once you're there, you should be able to see maybe a screen that is not identical to this, but something similar where you're able to log in into Globus. And if you could raise your hand or say something in the chat if you were able to log in into Globus, that'd be very helpful. Okay, I see someone's able to get there, so that's great. Okay, nice. So I hope we have 2 more people who raise their hands, and I hope everyone else is also following. Okay, we got more hands. That's great. So once you log in into Globus, you can go to the collections on the left tab over here. And if you go there, make sure to deselect this recent tasks because then it might not find it. You can search the collections that are present in Globus, and you can search for TMU and then, for instance, Grace. And here you want to select the Grace collection that is subscribed over here, so the one that's lowercase. This is the Grace data transfer node that we're using. And if you select it, you would see all the details about this data transfer node. All the different details, for instance, right. And we can open the contents, open this DTN in the file manager, so we can actually see the files that are stored on our Grace cluster using this button on the right. So if we press it, we will see the Grace has opened on the right for me right here. So if I look at the here it showcases my home directory, and I already created a Globus example.txt file beforehand. But if I go, for instance, in my Linux terminal, if I go to the home directory and I list my files, I would see Globus example here as well. So it showcases my files in my home directory. And I can also similarly open the Faster collection on the right. So if I search for it, I can also put in Tamil Faster. And I would see the Tamil Faster. Here there's access, and we want just the DTN one. And if we put it selected, we should be able to see our data archive on the Faster tab. So I hope majority of people were able to follow. If you were able to open these 2 clusters, raise your hand so that I know if everyone's keeping up. Should I go slower, faster? So once you've opened these 2 clusters, you can transfer files very easily. For instance, by just selecting a file on one side and just you can press the start button over here which will transfer it to the other node. For instance, in our case, it'll transfer from Grace to Faster, from right to left. Or I can just even drag and drop it. So it's very user-friendly. Or can I drag and drop it? Yeah, it did drag and drop it. And it would show that transfer was been submitted successfully. And if we look over here, it might not show up immediately, but if you refresh the list, which might take some time because the R clusters are very busy at the moment, we'll see that this Globus example was transferred successfully. And if we were to look it up at our Faster Linux shell, we would see that it has indeed been transferred. And moreover, Globus provides a lot of handy features, such as, for instance, the history of our transfers. So we can, this provides a lot of useful information. And I think I'll move ahead, just finishing some last touches of the presentation. So one last thing I want to mention is that we also have a data classification tool, which if you have some important information stored, you can run this tool to categorize your data based on the sensitivity of the information and categorizing on the impact of the potential loss if you lose this information. So this might be helpful if, for instance, you want to find out which information you should back up more, for instance. So, and you can read more about it on the using the link provided below here or on our knowledge base. And if you want to continue learning about more of our resources, we have entire playlists with more primers like this. We have our more short courses on YouTube as well, if you want to learn more about some more specific questions and tools about our resources. And again, we have our knowledge base, which is always a really great resource. So if you ever run into any questions about how to use our clusters or run into any issues, you can always check out our frequently asked questions and our knowledge base. And additionally, if you have further questions, you can always send us a ticket through the dashboard tab where it showed you the quota. There's also a button to send a help ticket. And you can also email us at help@hprc.tama.edu. And I also have see a question in the chat about Globus that requires access details. So I think when you were trying to get the faster on Globus, we have two transfer nodes. We have one for access, and we want to have one for our Tamu users that does not require access. So if I go to Globus, when I go into collections, and I try to search for faster, here there's the access faster, which would require you the access credentials, but the Tamu faster DTN should not require any credentials. And as such, we've made perfect time. So yeah, if you request any help, please provide as much of important details as possible so we can best assist you. So provide which cluster you're using when you send a help request for us, or your username, so we can pinpoint what specific issue you're having and do our best to assist you. And as such, I would like to thank everyone who's been part of this primer. Thank you for attending, and if you have any questions, let us know. And if you want to share your thoughts about how this primer went, you can always fill out our survey, and the link is linked here at the bottom of this slide. So thank you.